this is for our client in Chigwell, right? I spoke to her yesterday. They're exchanging and completing this week. They've had a budget estimate for normal construction, but they're keen to find out ways to value engineer it down, or even to shorten the construction.
Yeah.
The program, shorten the construction program.
Well, the way this compares, it probably be comparable in price, if not less, but the spec is higher. So when you're looking at things like during project management of a building, you're looking at time, cost, and quality. So generally, if you increase the quality, you increase the time or the cost, as you know. If you move one thing, it normally impacts on the other. The thing with the way we build, we increase in the spec because we're increasing the sustainability of the building. So if we build this way, and we can get the walls down to 0.13, which brings down the overall running cost of the building over time. If you build it the way we would suggest, you can get an EPC rating of A. An EPC rating of A, the energy performance of the building, great A rated, increases the value of the home as well. So not only does it make SIPS construction speed it up, it can help you in the build cost, but also in the running costs and increase the value of the property as well. So it's a win.
The big thing I think you missed out as well is it's an off-site build.
Yeah.
Okay, so it comes flat pack, comes in a lorry, flat packed. It's not weather dependent.
Not yet.
So you can. I've got pictures of us putting this up in the snow. We built a house in the snow.
But the speed is twice as quick, isn't it?
Yeah.
Well, the difference is with this building as well. A hybrid building is against any other construction. Traditional brickwork and blockwork is slow, and the walls are thicker, and so you need a lot of insulation in there. And the construction depth is thicker, a lot thicker. So you're losing square feet. And as you said in London, that's important. So the construction depth is thinner. It can be built in all weathers, and it goes up quicker. But also, once you get to roof level, you can load the roof up while you're doing the outside. So it takes all the walls and the windows off the critical path. So when you get to roof level, you can be roofing this at the same time you're bringing the outside rain screen up. So you're in a win-win on the programme.
Facade of building, say it's like either render, brick, cladding system, anything. The facade of that building comes off the critical path. Yeah. That can be put up anytime. Yeah. It's like when we built in Wentworth, we built concrete frame. Yeah. Only because that's what the client wanted. Yeah. But this supersedes. Yeah. No.
So when a client has got planning for traditional build and building control drawings are already designed, do the drawings change?
Well, no, what we've done, because generally what would happen with, you come to us with the planning drawing, so we can work with an architect. Yeah. So what you really want to know is the best, we're doing this all the time, we get the planning drawings from the architect and we say, hold on a minute, stop. We'll come up with a concept. Then a concept might not be, because you might get downstands, so you might need a big beam because you might have open plan. So the architect said, Andy, I don't like that one beam in there, we've got a downstand, can we put two? So two beams are going in there, so you've got no downstand. So we to and fro on the concept, so just to get the aesthetics right. But so from when we got the conceptual, then we've got a price because we know what we're building, and then we go away, we do an approval drawing. The approval drawing goes to the architect who checks it dimensionally. Once the dimensions are right, we go into detailed fabrication drawings and then procurement and making it. And at the same time, our drawings are fed into the architectural drawings who submit those for building control.
Yeah. Have you got your own architects in house as well?
No, we work with architects, but we have got some great architects we work with. Yeah, some sustainable. We have got access to our own architects, but not in house.
Do you think would most architects have worked with this system before, or not really?
You'd be surprised.
Especially in London.
You'd be surprised how
many.
They
would have?
You'd be surprised how many haven't.
No, that's what I'm saying.
What happens with this? You have to remember, it's a win-win because it's fast build, it's eco-friendly. But not only that, it gives you it's reduced construction debt and gives you a U value. If you build with this and add-on solutions we've got, you get a U value of 0.13. 0.15 and under, it's classed as passive. That's what it's classed as. Exactly, so you're classing as it's almost, well, it is passive fabric phase construction. So you're not building a passive house, but you're building. If you take parts of it out of there, it's passive. It's 0.13.
Yeah.
I mean, we can increase that
We've
U
been
value,
offered
but
quite a few passive house new build opportunities over the last 3 or 4 years. There was a lovely one in Wimbledon.
yeah.
But he came to us from an architect. Obviously, we've never done a passive house before.
There's no reason why you should go past. There's no reason,
No.
and I will explain to you. We've got other reasons. Passive means you have to orientate it to a certain. It gives you constraints. You're constrained to hell with it. Really, it's an architect's nightmare. It becomes box set and constrained. With what we've got with our renewable heating company, relieves you of these constraints, which we can talk about later.
Yeah.
So we've got a way of. Well, this is a fabric first approach, but we've got a way of heating the building independently, not through the glazing. Not passive.
These are concept drawings we did on Butter Street Rise, right? And people think about high-end properties and worried about this being a cheaper alternative. The chap who was buying this for a lot of money. It's a place just opposite the old Berkshire golf club, and this is what we designed as a concept. Okay. So these are concept drawings that Andy did. We got the planning drawings, and these are the concept drawings.
What's the size of this house?
It was 8,000, wasn't it?
Something like that.
Yeah, 8,000 square foot.
The other thing with this is, when we design it to give you room in the roof. All our systems are designed to, unless it's, with a flat roof, you've got a room in the roof, but a lot of these buildings don't have a room in the roof. So we do the concept of the roof first, and then we work down. So your load paths are going down through the building. So because you need a room in the roof. Generally, if you build traditionally, all your walls have got to go where they go, because that's the way it stands up. So you constrain, like all the walls have got to be built. We can make it, building this modern, it's called the modern methods of construction. We can open the buildings out, so we've got limited load bearing walls, which then allows you to walk the course after the event when we've gone and put partitions in. So you might want to move a partition a metre that way, this way. If you're building traditionally, you can't move them.
And not involve a structural engineer?
No, because you've built the structure. So we're designing one in Cannock now. We did it yesterday for the architect. The builders want to build a basement, and then they want to build a building on top of it, but they don't want constraint because they want to be able to go around with some spray paint and say mark it out after. So we're opening up all the spaces so you can walk the course in it, so you can move a wall 3 foot that way, 2 foot that way.
So I call it sort of it's always in the car park thing, because it's like building a car park where you have your structural stability in there, and then afterwards you infill
just
with
put the walls in where you want.
Yeah, but you've got when you're doing things like that, you've got to design where the windows are going to go, design where the penetration is going to go through the building for your services. These are the important parts that you've got to design out straight away. But all building work and all construction work and all design, architecture then, should all be done at the pre-construction. And then everything else should be easy after that. And a lot of people just rush into it. A lot of people go, right, well, we've got some planning drawings, let's get some architects to do it. And the next thing you know, you're halfway building the property and it doesn't work. So it's happened.
It also, when we design it, we can minimise some foundation strips and minimise foundations. So sending the loads to the edges helps you minimise foundation design. But also the way we do, when we're designing this, we're also all the time considering cold bridging, which is a major factor in sustainable building now, and the building regs in June. So we look at how can we mitigate cold bridging coming through. So cold bridging is just basically, if you had a wall like that, you've got a lump of steel here or something to carry a load, you've got to stop the cold coming from the outside to inside, so you don't get any what's called interstitial condensation. It's your dew point. So when cold meets warm, you get a dew point, and it's stopping that. So we design. We've got all standard details for where floors meet junctions and everything, so we can get rid of the majority of cold bridging we can eradicate. So you've got to consider all this, and that's what architects at the moment, they don't struggle with it, because most architects they enjoy the conceptual stuff, but when it comes to doing the engineering and opening up the building and considering, let's free up the space, let's consider cold bridging, that's where we come in and help them really.
I think it's obviously architects in London, they don't do many new builds, do they?
No.
So it's just getting, especially we work with a couple of architects in-house who need to get their heads around this for sort of mansards or maybe extensions.
On a mansard roof, we've done quite a lot. A mansard, a roof extension and everything. What you'll generally do is they'll either go up in brickwork and have to put a lot of steel work in there, and etc. So we try these. become these. Obviously, this will mitigate the need for steelwork because these become load bearing. But then when they're together, they act like a truss. So when it acts like a big truss, so it spreads the load across areas. You've got to look at what's in there and engineer it. You've got to marry it in. But the other beauty of that is it goes really quick. You're not like there for days and days. If you're trying to put a roof on an existing building, this does quick.
It goes up.
Well, we've got a few mansard pod rooms. We can try and flip them over to this method straight away, couldn't we? Really?
Yeah.
You want, again, your constraint with us is just giving us enough time to draw it.
Yeah.
We have to. We can't just say here's a load of panel, cut it and carve it. We have to look at it.
It's a design.
So your design stage, how long does that take?
It depends how big it generally from when an order we can have it drawn in. Depends how big it is in 4 to 8 weeks.
Yeah.
And then we have to procure. Week say 6, we're procuring materials. So we get materials in. So we're looking at from order to sort of like being on site 10 to 12 weeks.
Yeah.
And the whole idea is if you get at the planning stage, and get the architect involved, then that doesn't have an impact on the programme. It reduces the programme overall.
Because it's almost some of ours are already past that stage, aren't they? They're all oven ready. To be fair. Yeah. But the guy we're seeing on tomorrow, Wednesday. He may. Maybe there's something Will can start talking about. SIPs.
If you've got some oven ready, as you say, this is oven ready, really. Yeah. We can convert them.
That's oven ready because
it's just time.
I don't think is there a full tender pack on that, or only is there design drawings?
We've got drawings. We've got design drawings at the moment. So that one there, that's prime example. I mean, this one here, it didn't. They never had construction drawings, did it? They're Bud Street now, didn't actually. So that's where we took it from, the concept, and the chap loved it. He wanted to build it.
So that we can, one's ready to go and engineered. What you really don't want to be doing is paying for engineering twice.
Exactly.
But it's not generally. If we were in at the beginning, we probably could have took some of the steelwork away. We could have, with the way we built.
Mitigated it with the use of the systems.
The
structural system. Yeah.
So we can make savings. For argument's sake, we did a school in the Lake District, and they had £200,000 worth of steelwork in it, and we fabricate our own steelwork. We've got accreditation for a 1090, third-party accreditation for that. But looked at the engineering on it and removed up 200 grams worth of steelwork from it. So we did it without any steelwork.
So there's a cost saving there as well.
Yeah. So we built it without any steelwork, which permitted the school. The school didn't have the budget, so when we removed the steelwork. It brought the budget down, they could build it, and it got built.
The big thing that people get mixed up with is timber frame and SIPs, structural insulated panel systems. There's a vast difference. This is a system. This is a system between steel and panel, rather than timber frame, which is usually timber frame.
So how many years is this method been around?
It's been in America like 30-40 years. It's not new. They use polystyrene, but the difference between timber frame is you'd have probably a 9mm sheet on the outside, and you'd have studs that's 400, 600 centres, and that's what carries the load. So when you build a timber frame, it moves. So you load up the roof, so you have to look. They leave a gap above the windows and everything, depending on how big it is. And the building then settles down, which doesn't help with your bridging, your insulation, everything. So it shrinks, it moves, and that's the nature of the beast. With a SIP panel, what happens is because this is in an injected foam, it creates a shear bond on that face of the OSB, which you can calculate and you can test, which has been done. So they know the shear. It's a composite panel, so obviously with it being composite, it takes a hell of a lot of load. It's really, really strong. So across you've got a shear value there, which you haven't got with a timber frame, because you're poking insulation in and not creating no bond. So that removes negates a lot of timber, really. Stops any cold bridging, but it's absolute. The rule of thumb is like for like. If you was to build a straight wall there out of timber frame and out of SIPs, this would be 7 times stronger. Yeah. And it doesn't move. It does not. It does not shrink, and you can load it up.
There's less parts involved, isn't it?
Yeah. So you get traditional build house. You build it out of blocks and bricks, right? And you always get movement with the foundations, and you always get cracking. Majority of the time when you build out the SIPs, because it's a full structure, you don't get a lot of movement. You don't get a lot of cracking.
Why doesn't the big house builders use it, like Taylor Wimpey or Persimmon?
Because they use timber frame.
Yeah.
And why do they put roof trusses on a building? It's my bugbear. They'll build a house and not build a room in the roof, and they'll put roof trusses on because they're cheaper.
Because you drive by all these new built houses and you think, why isn't there a loft conversion?
Yeah.
Why is there not
massive big roofs?
Why?
Yeah.
With trusses.
Yeah. Why? Because it's cheap and fast, and that's what they know. They do not like deviating from what they're. So they don't deviate because they don't want to use the room in the roof, because they've got to get access there. It adds on for them. If you was building it, there's no way. But my argument is, when you build, if you want to save money, why would you build a pitched roof? Because when you flatten that roof out, there's the area. So there's the area of the roof. Yeah, that's the footprint of the roof. If you built a mono pitch roof on that, you'd get a room in the roof, and you would be able to insulate it, it gets rid of all the details, and it's less material. If you put a pitch roof on it like that, look at all the additional. You've got double the material for roofing it. It's as simple as that.
Look, some kind of flat roof, it gives someone the option to have a modular put on top of the
but it's as easy as, look at that. There's a pitch roof. There's other material. Flatten that pitch roof out of material. You've got double the material. Roofing, rain screen material. If you have a flat roof, you've got basically that. You've got the roof covering. So they're not really saving. So that's the plan. Is we could go and build flat roofs, and we can even do dual pitch roofs, butterfly roofs, and all. But they do, again, even if the planners make them go for a pitch roof, they should use the room in the roof. You can get a plant room up there, you can get your solar on there, you can get all the kit in there. Water travels down better than it does up. So all your plant room kit can go in there.
Exactly. All they want is that traditional looking house, don't they?
Yeah, but you can. But it's just all you need to do. Or the only difference is they're putting gables up anyway.
Yeah.
So make your gables support a ridge, and just put traditional, just timber it and insulate it. You can get a U value you don't have to use panel. You can get a U value of 0.13 using a traditional ridge. It's crazy.
We were discussing. You sent me this morning about the robots. Didn't you?
Yeah.
I mean, like what Andy's doing is getting robots now to basically detail, right? So we've got all these details here. I don't know if you can see that.
Where's that in your factory? Is it?
Yeah.
So that's the connection which we're doing on these like super luxurious tree houses, nice. £1 million tree houses, and that's the base connection onto a screw pile. So the robots will engineer that connection.
Yeah.
So we're looking at engineering, panel engineering.
So the robot will basically, one of these will engineer that. So that'll cost less to engineer because it'll be all set up.
Exactly.
And it'll just engineer it. So all the cuts and everything.
So that's an engineered timber frame, but not comparable to this. It's comparable to what you would see that structure inside. So again, when we're designing this, if you had sometimes when architects they might have a mini-mill house, and that beam might be steel, and we suggest why don't you put one beam in oak, just because it brings it down a little bit.
That's your end product from Six.
Yeah, that's it. Yeah, so
beautiful house.
So there's nothing really any detail that's any different. No,
it's got a fireplace in it with a log burner. What happens with a log burner? It brings the air from the outside and goes up the chimney, so there's no problems with air tightness. It's got everything in that building, and that's got a U value of 0.13.
And there's your concept, full concept 3D drawing to show you how the SIPs and the steel and everything works together.
Yeah, integrate. That model's built from different drawing packages and put together. Architects they call it a building information model, and they build it from like Revit and stuff like that. But we build our models from separate packages and bring them in. Basic. That's probably built in wood engine, and the steelwork's brought in, and we do a model from that. But that can be integrated into a BIM model if architects want to. But it's not. We've already done it. Because what happens with these floors as well, because you've got eco joists in the floors. You don't have to plot your path through for your M&E because you go straight through the floors, so it's not a problem.
So you don't go through joist, solid joist.
Yeah, so you don't have to really worry about running your services because you've got eco joists in there. And when it hits a piece of steelwork, we will put holes in the steelwork, so you've got holes and we'll frame them out. So that
there's a
thickness of it.
That's one of the houses we built. We built two for Brett now in Whaley Bridge in Derbyshire, and he loves it.
Yeah. It just must be so warm.
It is. Well, he's over 3 stories, and it's not finished. He's not got a front door. Well, he might have a front door on now, but well, he didn't have a front door on, and he had a 1 kilowatt heater in there, keeping the whole house was warm. A small 1 kilowatt heater was warm. It didn't drop below 17 degrees. So but he needed to put an extraction fan in. So when he drilled through the wall, you can see the construction. He's got a stone on the outside of that.
And it's I guess it's good for sound insulation as well.
Oh no, yeah, it's good acoustic. It's good.
Around here, you're right underneath the flight path, so everyone is getting noise feedback.
See, he's got stone, then he's got a cavity, then he's got a membrane, then he's got a slip panel, then he's got 25mm foil bite, and then he's got. So you can see our head. When the guys did the airtight test on that, and I can get Brett to do a recommendation on it really, but the airtight guy said he's never had it so good on any, and he's been doing it years and years and years, and that was the best airtightness test he'd ever got. He was pedantic on it. He did make sure it was right, and then like I said, what the beauty of it is, when you're in a SIPS building, because when he was building it, we got the windows. As soon as he got the windows in. He didn't have a door downstairs, but upstairs, the fluctuations in temperature from outside to in took 3 days to change inside, even though he didn't have a door on. So when it went cold outside, he walked in. It kept an ambient temperature. It took 3 days for the air to filter through the door with no door on. And when it was red hot outside, it was cool inside like a church. And that's why
Cotswolds would have been perfect for this, wouldn't they?
That would have been spot on.
You would not. You can video me saying this. I would not build any different way than that. That is the way I would build. I would build that way because it's a no-brainer. Because what happens with your floors? So if you've got a concrete floor, or you've got a beam and block, or you've got a raised floor out of timber or everything, you insulate above that floor. So insulate above the floor. And bring your insulation up to the panel, not directly because you have a bit of an expansion thing, So bring it, and then you get no cold bridging coming through the floor. So you're mitigating cold bridging. It's all to do with the junctions and the details. But I would never build any different whatsoever, purely time, strength, value, and the savings you're going to make over time. Running costs.
As I said, Will's been singing your praises for weeks now.
Yeah. Well, I haven't even started. I've not started yet.
No.
The other thing is you talk about acoustics, our floors, if we know, at the first floor, we can run a screeded floor on it. We can run 40, 50, 60, 70 mm screed on the floor, which helps with the acoustics as well. And you generally don't need to run underfloor heating at the first floor because it's too warm.
Incredible.
You put underfloor heating at ground floor just because you want to be absolutely red hot, don't you? You want your feet, you running across the... But people like it, don't they? So, but it switches off, because it's all about minimising kilowatts. But people like warm feet. You'll be red hot.
You will.
Will, is this what you've done in your house?
No, I'm going to put an extension on the house for this. So we're going to do 6. We're going to do...
it's lightweight as well.
It's
lightweight.
Near water. Using ground screws, because I want to get away from concrete, so we're going to use ground screws, and then we'll deck it out off the ground screws, and then we'll put the 6 pounds on there, the extension on a flat roof.
Which lends itself, you see, because if you've got an airflow underneath, it'll last forever. So underneath, if you've got a timber deck and you've got 150 of airflow underneath, that'll never, ever, ever rot. Well, saying that, but it'll last. And then you insulate above, so you've got no cold bridging coming from.
If the house caught fire,
it's the same as every building, same as any timber frame building. Everything, you've got timber. So what happens is the inside is fireproof with plasterboard, same as every other building in the world. So you either have half an hour or an hour, so you can use 2 layers of plasterboard, 1 layer of plasterboard, or you can use a thermocell board, or some corridors might need staircases in some places, fire.
But if there was a fire, would the whole building have to be ripped down? Because on a brick traditional, it would.
But if you use steel on a brick traditional,
it has to come down.
And the heat hits the steel. The steel is
bricks.
Come down as well.
The mortar petrifies in fires. Bricks do as well. It's exactly the same. This probably the lesser of two evils. Again, steel in an intense fire will buckle, whereas a big lump of timber will char, and charring gives it fire resistance.
So it's self-protective.
So not always, people think timber, it will burn. it will char and it gives itself fire resistance and it doesn't buckle. It's the charring what helps it. Whereas steel, you have to fire protect it exactly the same as you do with these walls. You have to encase it in intermittent paint or plasterboard.
Board it out.
You have to board it out because it's not. It does not have fire retardant properties. It buckles and collapses.
Will, you are right. He is an expert
in
this field, isn't he?
Listen, there's one thing I'm not.
Have you put this down in the book yet?
No, this will be the last time you ever said that to me. Expert. But we're not. We're always learning. I've met experts before, and every one of them's failed.
I know they're all about. It's all about learning. Isn't it? It's all about. It's all about.
Yeah, you're always learning. We're always learning.
You're always learning. But this is the way ahead. Yeah. This is the future. I mean, and people need to get on board with it. No, and architects need to get on board and specify.
There's no such thing as an expert, mate. Never. Yeah. No, you can have specialists and professors, and they'll never call themselves expert because they're always learning.
You're trying to invent with these other items new methods and technologies to go even further.
We haven't even scratched the surface on what we can do yet.
Okay, well, I think we've spoken enough about SIPs. We're going to definitely be bringing this on board with these, obviously, Chigwell and maybe these loft conversions and mansards.
Everything.
Extensions,
and even if it's got lots of glazing in it, lots of stuff which doesn't need insulation, we could do the steel frame for you.
I think we need to do it even as traditional. We need to create a sort of promo video of maybe in his factory, walking around showing different kinds of things, and maybe even we'll go up, or we all go up there.
We won't show because this factory's small, so we don't want to show the size of the factory.
No, just individual products.
Yeah, we could do it. It probably was more like us building buildings and bits and pieces.
That's better.
Because you don't want to give away what you're doing.
No.
So if you've got a site, we can visit and show it.
But Bedfordshire's not too bad.
Bedford, because we're working with the robot guys. Yeah. The house with that one I just showed you is in a prime state to take some videos of now.
So that's where we put Bedford.
Let's go there.
They'll be brilliant. They'll be up for that.
Yeah, 100%.
Because the ground floor is still at this state, and we've got the internal walls. It's got the heating in the internal walls, so we can find out. We're doing 20 kilowatts of solar in his field. He's got 3 acres outside, so we're putting all the solar in there, running the solar cables. Then we're doing a 300 litre buffer tank for his underfloor heating, 240 litre domestic hot water tank, and then again we're heating the concrete walls, which I'll move on to in a minute.
Amazing. Well, thank you.
No, excellent.
So that's the SIPs.